Hey, what's
Hello.
up?
Uh, all right. So let me just note in the Slack that we're starting. Audio is still not here. Oh well. Okay. So welcome to the virtual brown bag. This is our weekly online developer meetup. Ooh, there are links. Cool. Actually, here I'm gonna. Okay, sorry. Let me finish that. This is our weekly developer meetup. You we invite developers to join, basically do a show and tell. Just a reminder, everything is automatically streamed to YouTube, so don't share anything that'll get you in trouble with your employers. Um, that's pretty much it. This is the first time that we are using YouTube Live since they're about to force a switch. This is also the first time I'm starting the meeting as opposed to JB, who is off starting his new job today. So there is doubtless going to be some kinks to work out. One of the things I want to check is how the viewer link might work. Um, so actually, I'm curious if you join via the virtual brown bag site, if there's a different link that if you get the link but don't get to actually participate. Um, Maybe we can check that kind of toward the end if we have time. Uh, in the meantime, hey Ed, hey Seth, you guys have anything y'all want to talk about?
I've been this weekend. I worked a little bit on a React Native project that I could
Hmm,
show off.
cool. Yeah, and I know we were talking about threading and C sharp and stuff like that,
Oh yeah.
which we could always talk about some more.
Yeah, I was reading
Hmm.
about that, and it's hard sometimes to find because that book, a little bit of C sharp or whatever, is
Hmm.
a lot of C sharp. It's like 1,100 pages, right? And
Yeah,
I'm just trying
right.
to get sort of a feel for the most important, and obviously it's not exact science, finding the most important features, but it's like get into reading about enums and these data types or these collections that and then you find out, oh, this isn't really used in the wild, and so
Right. Well, I can tell you, I mean, threads at least are very important to understand, but you
mhm.
don't actually end up using them direct. Usually, you just kind of let the framework do what it's going to do anyway. That the different web frameworks and so on will do very nicely for you. They'll handle all of that. You want to understand it and you want to get out of its way as much as possible. Use async and await and so on, but really don't. I mean, you're not newing up threads hardly ever,
Right,
unless you yourself really want to go down to their level of coding.
right.
But that's what you get with a general purpose programming language, right? Yeah, I didn't know if you wanted to talk about that more.
Oh,
Um,
yeah, I didn't have any specific questions about it other than
okay.
I'd like to know if it was actually being something that's used because it's like, okay, so await and async, like just like in JavaScript, it's syntactic sugar over
Right.
something. And so in the examples that it was, classic, so like they were using the sleep function basically to illustrate async, and I was saying, oh, so are we actually like appending, like using thread, the method directly constantly? It was a question that was in my mind as I was looking at this example. Is this actually the way that people are using it?
So you can use await to sleep, but it's well, wait, how were they? So they were doing thread.sleep or
Yeah.
task.delay? Because those are actually two different things.
Oh no, they were using like thread dot. I think it was actually inside of a thread. It was a task dot run or something, and then
Okay. So task.run
Right.
is going to take the lambda that you pass into there and say, hey, anyone, and basically this needs to run. After that, what happens is you get to the task scheduler. So think like kind of like the event loop in Node, right, where it's taking the next thing and stuff like that. Except the event loop, except first of all, it has access to multiple threads, so it might choose to run things out of order at the same time. Second of all, that's kind of neat about the test scheduler is it's extensible. So you in Node, you don't get a chance to, you can't say like, oh, I'm going to modify the event loop and to give all calls to this particular function higher priority. That wouldn't even make sense really in Node. Well, it would make sense, but you can't do it.
Right.
Well, with .NET and the task scheduler, it's an extensible mechanism, so you actually can. It's very explicit. But basically, the task scheduler is going to look at what threads it has available, whatever optimizations they've written in, and take that code and run it on those threads as needed, finishing out that task when that finishes. Now, what happens when you have a thread.sleep inside of that thread is basically it runs until it hits that, and then the thread doesn't end, but it has nothing to do. It's kind of similar to saying, while true, and then just like looping until the system time is equal to a certain time. It's not exactly the same, but it's kind of in that area. So what happens is the thread runs until it gets there, sees it, and says, all right, well, I don't have to do anything, goes away. Eventually, the operating system will switch that thread back on, at which point the thread finishes and the task is complete. So really, the only time you want to use thread.sleep is when you want the thread to sleep, is when you're like, oh, okay, I am on a thread for this period of time. I want this thread to stay alive and kind of active, but not do anything. Now that we have a much better pattern, actually, if you want just some amount of time to task, is to use task.delay and await that, which basically says, hey, take everything that follows this and then run that into continuation. A promise, basically, they'll resolve after this amount of time. So that puts it back on the event loop. In fact, when that code runs again, it might not run in the same thread, right? Because it goes in the task scheduler, and when the task scheduler now watches for when that delay is over. And when that delay is over, it's going to pick whatever thread is up for and start running it. It might be on a different thread. That's not something that actually matters very much, and it's actually more efficient. But it's not something that's going to matter very much unless you're using like stuff like thread-specific variables and stuff and things like that. But it's probably not something you're going to have to worry about. Does that make sense? And then
sort of. I was trying to think about how it would sort of translate to promise or promise.all or something. Like a task is almost like a group of promises, correct?
No, a task is a promise.
A task is a promise.
It's technically, okay, if we go down the level, a task is an implementation of what's called an awaitable, which is, there's a couple things in C#. So you've learned about like interfaces in C#, right?
Yeah.
There's a couple things in C# that are built into the language, which kind of seem like they would be interfaces, right? Like awaitables is anything with a get awaiter method.
Right.
You
can hook into the async.
Yeah. Interestingly enough, there is no interface with get awaiter on it. You can actually await anything with a get awaiter method, including extension methods. You can write an extension methods on time span. You can write an extension method that extends number, right? Any integer. and says whenever I do 5.getAwaiter, that's basically gonna mean sleep for 5 seconds. You could do that, and then you could await 5.
So you can use task.run or await, and it'll do basically the same thing.
No. Okay, sorry. I jumped into it. I confused it a little bit. So okay, task.run says let's I'm gonna share my screen. I'm gonna start some code up. Hold on. Have it at least not be how do I edit buffer? I'm just trying to empty buffer. There we go. Base max.
Right.
But there's some pretty cool stuff I found in there. All right.
Yeah.
So let's see. Do I have the option for C# mode? Oh no, I can't get. I have Java mode. Sure, whatever. That's close enough. Let's say. So let's say static class food. So we get our syntax highlight. Public static class main. And there's our. Right. So there's our method that we're running. So inside of it, let's say I do. Well, actually, I'm going to create another class because, and we'll go over why that's in it, why you can't just do it right there, because that's going to be our main entry point into the application. Public static sync. Oh, actually, I could put it in the same here. Sync task stuff. So let's start with this. So if in here I am doing await task.run.
And then correct me if I'm wrong. Underneath the
Mhm.
that's the I guess you'd call it that's a function statement. You would put like the task just like in JavaScript that so when the do stuff or sorry when task.run resolved it would just yield to the next function call.
Wait, okay, say that again.
And so what I'm thinking is in that code block right underneath when
Right here.
task.run resolved.
Resolves. Hello? Oh. Oh. Can you hear me? Hey, can you not hear me? Hey, can you hear me? Oh, we lost Seth. See, when I was looking, everything was frozen. Let me see if he's. Oh, is your mic not working, Ed? Oh, that's a pain. Um, yeah. Let's see. Well, it looks like he realized it, so he should be back soon. Guess I can finish typing out the example in the meantime. All right.
Hello?
Yeah, there you are. Right.
Sorry, my computer restarted. It's a MacBook.
Fun.
Yeah, fun. Oh,
That's
I
okay.
was just,
Yeah.
you can switch
Yeah.
back to your screen. Oh, yeah, I was just saying it works the way that you would in Code.js, where it yields and then goes to the next one. Okay.
So, hold on. So there's actually is a little bit of a difference. Like it. So if I was to run this, and actually, in order to run this, I would have to do this. Do stuff. Wait, and we could talk a little bit about why that's the case in a bit. Um, if I was to run this, what order would things print out in?
Um, well, presumably console.writeLine goes last, right?
Well, but there's three
Yeah.
console right lines, right? There's 1, 2, and
Oh, yeah.
3.
Yeah, okay, so three should go at the end. And then it's just the functions. I guess one. I mean, it should go 3, 1, 2. Wait, what's the?
Yeah, so it probably will, but
Okay.
not actually necessarily. Because remember, unlike what you're doing with Node, when you do this, right? When you have this block,
Hmm.
you do an await or a start promise or something like that. It's basically scheduling it on the next event loop, meaning 3 will run first. What happens here is it gives it to the task scheduler. The task scheduler could perfectly reasonably, it could say, hey, I actually have a thread right here that's available. Let's start running it. In which case, it might go 1, 3, 2, right?
Huh.
Um, or even in, again, like I said, it's extensible. It might say, hey, I'm in a single thread environment. I only have one thread to run this. But the logic that I've been extended with says I should run anything that awaits now currently. In which case it'll be 1, 2, 3. That's
Which is the behavior that you want, kind of,
no,
right?
not necessarily.
I mean, if you're doing task.run and then you're doing you want that thing to
Okay.
run and then you want it to resolve and then you want console.writeLine 3 to run. That seems like in JavaScript, if
Yeah.
you were having an await keyword where you were like, I would want this other thing to run actually at the end, it's like, no, you wouldn't write it that way. That makes
Yeah.
I don't see
Yeah.
why. How the order can be confusing.
So let's do it this way. Await T. Okay. So, okay, yeah, this is actually a clearer demonstration of it. So it is actually possible to get 1, 2, 3, 4 if the situation is such that, well, actually, no, never mind. Never mind. I don't think it is possible to get 1, 2, 3, 4 because right here you're creating a lambda. No, wait, yeah, it is. So right here you're creating a lambda. You're not making you're saying this starts running right now, right?
You're right.
It's only after this that you're saying wait for it. So what happens if you
Oh,
are in a single threaded environment?
right. So it doesn't know that it's single, but shouldn't the async keyword on line 1, like, I don't know,
So that's the thing. That's
or
something the
line 2?
task scheduler itself knows,
Okay.
right? The task scheduler knows how many threads are available to it. So if there's one available to it, say, okay, well, just run through it serially. Everything's on the same thread. Go, 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 go. And then by the time it gets to line 5, well, it's already complete. So it finishes. Now, most of the time, that's not what's going to happen. Most of the time, this will start, and you might get either 1 or 3 first, right? Because it starts running right away, but there's no guarantee if it gets scheduled into another thread. Well, the first bit of instruction on that thread might be to write 1, but the thread itself has to get set up. So it might do a bunch of work to set up the thread and transfer this code to it, and then execution gets pulled before it actually gets to that first line of code, in which case it would go 3, then 1, then 2, then 4. But it also might be that it does get to it, so it'd be 1, 3, 2, 4.
Huh. So the only way to
Does that make sense?
guarantee it, kind of. So how do you guarantee the order? Like, what's the? I mean, because we're talking about a
If
situation
you're
like order
using
now.
threading,
Uh-huh.
if you're using threading and you need a guarantee ordering, you don't you when you're using task.run,
Mm-hmm.
you are saying that you are saying, hey, if you have another thread available, start this on another thread. So first of all, maybe you just don't want task.run if you care about ordering, right? If you care
Yeah,
about
well,
ordering,
within the, gotcha. Well, within the task.run, the body of task.run, you said order can get confused.
no. So 1 will always happen before 2, but there's no guarantee of whether 1 will happen before 3 or not.
That's
But you see why though? Because here, check this out.
because if thread.sleep.
No, actually, yeah,
Create
let's get rid of the thread.sleep. It's still the case.
It's still the case? Okay.
Yes,
I
because
don't know why.
so let's just put some more code here. That right, do this, and we'll do 9 to the 900 or whatever. It's gonna calculate and output some really big number. I don't think that's actually even C# syntax, but you get the point.
Right.
So it's going to calculate, or we'll do this. We'll do the prime number. Right. So it's going to calculate some primes.
Mm-hmm.
Okay. So let's say you're in a multi-threaded environment.
Mm-hmm.
Right. That could take, I don't know. Let's say it can take like 50. Let's say it can take 10 seconds to run.
But how do you get into a multi-threaded environment without being explicit about it? Like, I don't totally understand. Like, in a normal...
normally it's multi-threaded. There are multiple threads available. That's normal. That's when you run an application on a computer. Most programming languages, you make use of multiple thread. Will make use of multiple threads. Node is actually pretty unique in that it only uses one thread ever.
Huh. Okay. And so usually when you want to guarantee order, if it's, I guess there's probably directives you can give. Wait a second, but JavaScript is single-threaded.
I'm sorry?
JavaScript is single-threaded.
Yes,
right?
JavaScript is single-threaded, Node is single-threaded.
Right.
Yeah, JavaScript, the semantic of it is it's a single thread doing everything.
Which I guess makes it easy to reason about. But
yes, it's also its biggest weakness because you have to jump through a lot of hoops to use, in Node, all the resources your computer has to offer.
Right.
So here's the point about how things can get out of order. So let's say, let's say we're doing and takes about 10 sec, right? So let's say what happens is this causes a new thread to be created. Thread. This is, well, actually, this is actually going to be thread C. This is going to be thread B. There actually is a thread A somewhere else that we can talk about later. So thread B is out there. This is still going to be thread B. Because what thread B does is it creates the task. The scheduler decides to put this on the new thread. So let's say you run this right here. Prime number takes about 10 seconds. It gets about 8 seconds through. and the operating system says, okay, this thread is taking too long. It's actually a lot shorter than 8 seconds. It'll probably be in the order of milliseconds or something like that. It's going to yank execution from the thread, because that's what scheduling and thread scheduling is all about. The operating system is constantly pulling execution from one thread and giving it to another and giving it to another and so on. That's the reason why, I can alt tab and switch to an application. That's the reason why I can talk to you in Google Hangouts while having Emacs open, right? While having all these other applications open. Each of these applications up here has one, probably many threads working for it, and the operating system is just very rapidly changing in between them, right? On the order of milliseconds and even nanoseconds. So it's going to start calculating the prime number, and at some point that thread execution gets yanked away. It goes to Alfred, and then it goes to iStats, and then eventually it comes around to execution of thread B. Well, thread B, the next thing that happens is that it's going to write line 3. And now it says, okay, we're not going to continue execution here any longer until this task completes. So what happens here is that actually the compiler will take this and convert it into a lambda and put it inside of a continue with on that task. So this is actually the same as t.continue with. It's not exactly the same, but it's close enough.
What does continue with?
Okay.
I mean, I think I
continue with is like a vet is like a dot then on a promise.
Oh, okay.
That's the key. That's why I keep saying they're really similar to
Gotcha.
To the concept promises. So basically, when it sees this, right, when it sees an await keyword, the compiler, actually this happens before the code runs. This happens when you compile it. This is actually what it becomes. There's a couple other things in there, like checking whether x.exception is a thing and unwrapping results and so on. But really, this is the core of it. So anytime you see this, you should think that's equivalent to this. And if you have multiple awaits, well, it's nested down and so on. It's just, it's having continue with within the continue with and so on, call back out. Right. So that's what's happening here. So in that case, you have 3 run first. Now it's waiting. It gives up control of the application, right? Now you're back to here, right? So that takes about 10 seconds. Now you're back on thread C, right? It prints out a prime number, it prints out 1 and then 2. And now this thread C dies, or rather it gets returned to the thread pool. Eventually, next, the task scheduler works around and says, hey, T is unblocked now, so this can continue working. And this is going to be, and it'll launch this and it'll relaunch it on.
So if you move the await keyword, it'll
launch.
This feels similar to JavaScript. If you use the await keyword, it's just, I guess, things are a little confused because it's in a multi-threaded environment. If you move the await keyword up to, like, if you switched it with...
If I moved up here?
Yeah.
Then, in that case, 1 and 2 will always print before 3.
Right.
It won't get past it. Right. Now, if you want to make sure it prints 1, 2, 3, 4 in order, you could do this, but why would you actually do that?
Yeah, you would use.
Why would you use a task run at all then?
Yeah, a task runner you're saying is meant for when you've got bigger jobs.
Yeah, and
to put them in when you don't care about.
Yeah, where you want some stuff to just start running kind of in the background. Right. It's not something that you use very often in day-to-day stuff.
Right.
It's an optimization.
Would you use it in I guess I don't know what the equivalent of an AJAX request is. But I'm sure you can.
So you don't actually have to. So if you think about it, what the web server itself is doing is firing off tasks that runs, right? a web server can serve more than one request at a time because it's handling scheduling and threading and so on. What That's kind of the core of what web servers do. They say basically, um, they basically say, I've got uh, you know this web server is going to have 15 threads available. So go ahead and as request one comes in, give it to thread A. As request two comes in, give it to thread B. Request three comes in, tell it to wait a bit, and then reassign one of the other threads to it. So that's basically what the core of what web servers do is manage your resources to and give and hand them off to requests to run them as they want. Now, if within a it is possible, like within a request. So let me think about the last time I've had to do this in a web application. Okay, so there was a situation where where you would hit a URL for me, and that meant that I needed to start calculation, basically do a bunch of web queries and like 50 or 60 web queries using like external tools, and then take the results and compile them into like a big report and so on. Now, my request, the actual URL that they were hitting, it wasn't to download the report, because if it was to download the report, I would do it right then and there. It was to prepare the report and head back an ID, and then later on they would query for that report by that ID. So basically, when they hit that request, all that I needed to do was to generate an ID and give it back to them, and then in the meantime start the calculation, the querying, and so on in the background. But I didn't actually have to wait for it to finish in order to give them back the ID. I just had to make that association. Here's an ID, start the report generating with this identifier, and then later on, once they could hit a URL with that ID, and if that report was ready, they would pull it down. So that's the kind of situation where you end up using this, where you really need, like, you're like, I can just return, I have something I can return now. I just want some stuff to start running in the background while I do so. Which is, as you may imagine, is not a super common situation. It comes up like once a year or something like that.
No, I'm
In
curious.
very
It's
specific
weird because I see a lot of talk about like web workers and all this stuff, and I've never really used.
Well, web workers are entirely on the client side.
Yeah,
As far as
true.
the
But when
server
you
is
have
concerned,
when you have heavy computation, I guess.
yeah. So web workers, it's a little different, right? Because than what I'm talking web worker. If we were talking about um, having if we were talking about this being a desktop app as opposed to a web app, then web workers are a better analogy. The thing is that if it's a web app and we're talking about requests and so on, well, there's very little reason to do it because, like I said, the server's already handling the request scheduling and mapping into threads and so on. If, however, when you have a UI, a desktop application, well, that's persistent. The threads are around, and there's a lot more reason now to like spawn off little background processes for computation. So JavaScript with the concept of web workers maps a lot closer to that. There's some caveats though. So web workers themselves aren't really like threads in that they actually they can't access the same. So threads can access any variable. They're working against the exact same memory space as everything else is. So they have access to the same heap. Remember, we talked about heap and stack and so on. So they have access to the same stack frames and the same heap. They just kind of have their own path through it. But if a thread goes ahead and changes a property on an object, it changes for all the threads, because they're all accessing the same memory. With web workers, it's actually they actually are have their own memory space that they're working within. They're never going to overwrite each other's
That's
variables, and the way that they can communicate between each other, between the main thread, is only by sending strings. So
oh,
it's
so
actually
it's actually really a big hassle that do like if you have to actually do it a bunch of times, you have to pass the
it,
variables like through.
yeah, you have to pass JSON form and decide how to merge that into your current memory state and
Right,
so
right.
on. It's not exactly bad or anything. That actually makes reasoning a lot about it much simpler, which is, JavaScript's not meant to be this huge complex multi-threaded beast, but it makes reasoning about it a lot simpler. I think and it's actually a lot closer to when you talk about having multiple processes launch. And well, it's actually the exact same thing. That's how do you do multi-thread? How do you take care? Your computer has like 16 cores probably. How do you take advantage of 8 of them if you're running a node application? Well, you have to do child process, which actually creates multiple processes, and those processes can communicate in some ways, but they all have their own memory and just have to pass strings basically back and forth. So web workers work in that exact way. If you remember, kind of when we were talking about Elixir or Erlang, there it's kind of similar to that as well. Um, they kind of work their own separate way.
The actor model or something. I don't
Yeah, exactly. The actor model, where each actor is its own self-contained thing. They're not working against the same variables and memory as everything else. It's really a much simpler thing to work with, and I think that's what's important. Um, cool. We good with this? Do you understand, by the way, why I did this right here? Dot wait.
that way. Well, the main I was reading about this main, so basically that's the entry point to your application. And so
Mm-hmm.
like the dot wait, presumably it starts all the I mean, I don't understand like normally if this is JavaScript, the entry point you would be calling do stuff, but this isn't the case. You're actually calling
Right.
do stuff dot wait, so you're calling do stuff and then for and then like you're passing in the value of wait of whatever wait to the do stuff um, like to whatever to the at the very end. I don't know.
So what? Yeah. So you're kind of right. So basically, when it gets into main, right, that starts a process, and it's got a single thread that's running. That's thread A. When you call do stuff dot wait, so here's the problem. It would be great if I could do a wait do stuff here. I can't do it because you can only use a wait inside of methods that are tagged with async.
But why would you
Main is
even do a wait? Like, why wouldn't you just do stuff? That's my question. Like, why
that's
am
a
I?
good question. You wouldn't. Yeah, you would realistically not. Yeah, you would just say, okay, start running on this thread.
So do
You
stuff
were
returns an
correct.
object. Correct.
Do stuff returns a task.
Oh, okay.
So actually no, actually yeah, there's a reason you don't just do stuff, because because if you do just do stuff,
Mm-hmm.
it might go okay. Then this will be thread A, right? But it'll go that. Um, but remember, what it's actually doing is this guy right here. So actually, let's rewrite it without the wait. So what it's actually doing is this: t dot continue with our new task equals that. We'll say t2 like the terminator, and we'll say return t2. So that's kind of close to what it's actually doing that way, right? That makes sense.
Yeah.
It's return the task. So if I do just this do stuff,
Mm-hmm.
what guarantee do I have that this right here has actually run? at the time that it returns. In fact, what it's going to do is go do this. It'll start our thread running. It'll always write 3 out. It will wire up this continuation. It'll return our task. And then that task just kind of goes away, disappears into nothingness. And then as far as it knows, the program can end. Yeah, there's still a thread out there doing some stuff, but that in itself doesn't keep the program from ending. There's always threads out there doing stuff. The process shuts down, the thread ends. So
So
probably
you
never,
might end it prematurely.
yeah, it will never finish calculating a prime number probably.
Gotcha.
Yeah.
So,
So
because there's a special thing that says like, hey, don't, because that to me, I didn't know that. I didn't know that.
yeah,
I thought that like a program ends when all of the threads, like I assume that it kills,
no,
everything kills, and then it waits for all those things to
yeah,
die.
and it actually can't because there is one program always running, one thread always running, because that's the main thread. You can't have a process without at least one thread, I don't think. So so there's one thread that is core to the process. The only time that you actually exit is when you like reach the end of all so the only time you actually exit in a .NET application is you call it something like, I think, environment.exit. That will kill your process. I think there's several different ways to do it, and I mean that's implicit on the last line of the main, right? That's what happens there, and that's the only time it's actually going to end the application. Otherwise, it's just there and running, and the one thread that it has is spinning forever. And that's what happens here, actually. So thread A just goes ahead and spins forever. Now, it is weird because now you have like thread A and B and then maybe C. So if you wanted to be less wasteful, then maybe instead of making this async, you would just go down here and say, okay, wait on that. And now you don't have thread A and B and C and so on. But at that point, you're really micromanaging. It's better for readability to do stuff this way. Now, again, dot wait is not something you do very often. Again, if you're running,
you want to use the async keyword,
right? But you can't because this is a console app in this example. If this was a web app, request functions, they support the async keyword, which is great because basically the framework itself, the web application is not going to shut down just because you're not in a request. It's still running. So it's managing all that stuff. However, if you have a console application, that's your entry point. There is nothing higher up to manage it, right? So you can't put an async keyword because remember an async, well, it's not so much the async keyword itself is not expensive, but it's more that there's no point in returning a task from there because there's nothing higher up that can say, okay, wait for this task to finish and then call process.exit. There isn't a level higher up to do that.
right?
Right there, and it starts and ends with you.
So this is a thing that literally has to do with just being on the main thread.
Yes, exactly. Yeah.
Or the main. You call that the main. It's the main thread. When you say the main thread in C#, do you mean everything that happens within the body of the main function? No, you're talking about.
It's usually yes. So that is going to be the main thread. It's not everything that happens within the body of the main function. I could take this, right? I could take our T and move it up there.
Mm-hmm.
And that's still getting a new thread, right?
Right.
Yeah. But it's still in the body of main function. But yeah, the stuff that starts executing there now, one of the things that will usually do, again, we're talking desktop applications, but you do something like application.bootstrap, right? Which will start your screen, all your screens and UIs and so on. From then on, when you say main thread, what that usually refers to is the UI thread. So pretty much every single UI framework out there, and I'm actually not 100% sure why this is the case. I mean, you kind of get it, but it doesn't seem like it has to be as overwhelmingly in this direction as it is. But pretty much every single UI framework on there, only one thread is actually allowed to update the UI. And that's actually the case with JavaScript and HTML as well. That's how come if you do a while true spins, your UI freezes and you can't click anywhere. It's because it's one thread. Only one thread is allowed to update the UI, and that freaking same thread is doing your JavaScript. Now, in most applications, that's probably not something you want. Get out of the JavaScript model. That's probably not something that you want as much. You want to be able to kind of have your UI thread running and being responsive. User clicks on something that requires some backend processing, you spawn a new thread to handle that, and then once that finishes, it returns control and creates some sort of message about the fact that it finishes, and then notifies the UI thread to update the UI somehow. Does that make sense? So basically, JavaScript is actually the exact same way. The thing that saves JavaScript is that nobody ever really does all that much with response to like a click or a key up. Like all you're really going to be doing when you click on a button, okay, you maybe add the first name and last name, you do some calculations, maybe Angular or React does some stuff for you, and then you fire off an AJAX request, and then everything after that, gets put on the event loop. So control returns right away. That whole thing takes like maybe 4 milliseconds, probably less. So and now the UI is responsive again because you're not doing anything. And then when the AJAX request returns, it grabs it again. You can't actually interact with the UI while it's processing the AJAX request, but it's only doing a couple of things here and there. And that's it. So the thing that saves JavaScript from this is the fact that the interactions, the actual time that your JavaScript code is running is very, very short and very sporadic. If you wrote JavaScript code that took like a second to run, like front end, right? It was that much code, it would be a real problem because the UI would be unresponsive in that time. So when I say main thread, I generally mean the UI thread. That is the only thread that's allowed to update the UI. That was a lot of stuff that I just said, I realized.
Yeah, I'm following. I'm imagining that there's situations where you do a couple of things, but when you're the UI thread, so if you were drawing something, like if for example when you clicked something, it was drawing a thing on a canvas node, right? It was like, let's say you click letters and it was drawing those letters. Would you consider, is that the UI thread? I mean, no, right?
No, the UI thread would be what's doing the drawing of the canvas. Yeah.
Oh, so
the UI thread.
So you would have to throw. You can use. I mean, you could presumably use async to deal with that. Right?
Well, no, not really. Like, let's say you're drawing stuff on canvas. First of all, drawing stuff on canvas is by design very, very fast. So and also what it's actually doing, it's not really drawing stuff on canvas, probably, rather than it's saying there should be, we need these, and these pixels lit in this particular situation, and then that information is sent to the graphics card. It doesn't necessarily have to wait for the graphics card to acknowledge and say, yeah, that finished.
Gotcha.
It does, because the graphics card just starts processing stuff and it's lightning fast.
But there is fast JavaScript games, correct? I mean, there's games in JavaScript. That seems like that's a lot of calculation.
It
Like,
is. Computers are pretty darn fast. I mean, that's some of it you can get away with like web workers to help, right? So let's say you have you're doing a bunch of calculation. Let's say like there's some game that has to do a ton of calculation about bullet trajectories and so on. Well, if you can push any of that calculation, that means it doesn't have to happen in response to something. Let's say you walk into a room in your 3D game and it's once it starts working out all the like the major types of bullet trajectories that could happen and that kind of basically building up a cache. Well, you could put walk into a room, it fires off it, you walk into a room and it fires off a web worker that starts calculating that cache, and then ideally by the time you need to know a bullet trajectory, it's something very similar to it is already in the cache. So that's basically how you could get around it.
but you'd have to get around it. That's the thing. I wonder then how does that mean that functional languages that are, I don't know, like closure scripts or something. I don't know.
Yeah.
Like, how
What
do
do you
you
mean?
have it where you're trying to do all this pre-calculation? Um, like, so before,
Yeah.
so it's not quite an event-driven model because it's doing all this calculation in the background.
Well, so functional languages get along just fine with that, and part of keep in mind that part of what functional languages really get at a lot of the time is lazy evaluation. So you set up code, you're saying like this is the code that needs to run in order to know that value, and it will run that code whenever, but you're not telling it actually run this code right now.
So it needs
You're
the,
telling it this is the code that needs to run in order for me to know the answer, and the language itself, the runtime, is free to decide when to run it. So it might actually, in most cases, it's probably best policy not to run any code until you actually need the answer.
right.
Once you run it once, well, if you know what all the dependencies are, which in strongly functional languages you do,
Hmm.
right? You can cache answers and so on, and you can cache it at like the language level. Or you could decide to you could have the make it a little smarter and make it be able to pre to do some calculations. And I mean, honestly, if you think JavaScript doesn't do that, it absolutely does that. That's what a lot of like V8 crankshaft is it's monitoring your application as it executes and kind of making some assumptions about how it will execute, and then just going ahead and doing that, and then monitoring what your application actually does. And oh wait, if it did something different than its assumption, okay, it'll take a step backward and reevaluate that code anew. But yeah, there's I mean, the witchery of getting JavaScript to run fast absolutely involves a ton of that. Probably, possibly more than any other language, honestly. That's why it took so long for them to figure it out. And it took, what, 11 years or something?
Yeah, and three different giant billion. Someone said, I forget who said it, Steve, billions of dollars. I was like, wow, that is a lot of money to invest in a JavaScript compiler, right? Or
Yeah.
anything, or basically anything. But that's the case.
Well, yeah, but the fact that V8 came out was the only thing that made Node feasible, right? Because JavaScript on the server existed before. We existed plenty, but JavaScript, nobody considered JavaScript fast enough, really.
To
And
actually
that,
do it, and as you were saying,
yeah,
it's I mean, like you wouldn't say like Express.js spawns a web server, I think, but I don't know if does Node have a web server process, and then
it
so
does. It has
I guess I took it for granted,
yeah,
that thing was sufficiently performant and that wasn't actually a hard problem. But
yeah.
as you were saying, it actually is a hard problem because web servers really work best in multi-threaded environments. Um, huh?
You there? Seth? And we're frozen again.
Sorry about that.
Yeah. All right. Yeah, it can be a hard problem. I mean, look, I said this before. There's nothing really special about Node. It came around at the right time. V8 is way more special than what Node did. I mean, and it's not like Ryan Dahl is delusional about it. Like he started Node, where Node came from when he was like, this V8 stuff is really cool. I wonder how it would run on a server, like how to get it running on a server outside of the web browser. That's where Node came from. That's it. And it's just doing that same stuff, the V8 stuff, and yeah, and like then of course all the other JavaScript interpreters take those same ideas and have been using them as well now.
I guess I have a question. So when Node gets a request, it has all this, and it's, let's say, it's spawning threads for each one of that request. Is that the web server's responsibility?
Nope.
No.
Node will not do that.
Okay.
Node will not spawn any. Node has just a single thread. That's it. That's
so
it.
How does
Node
it
has
figure but you're saying like okay, so it figures it out. I mean,
how does Node serve 100,000 requests?
Yeah, in the way that if you're saying like that, like that's what that's what makes multi-threading on the server very powerful. Like how does it?
So here's what happens.
Drop it in.
So basically what's going on with Node is that the kind of the other innovation that Node did is also the thing that everyone hates the most about it. When you want to know the contents of a directory, you have to use a callback to get the response, right? When you want to read something from the database, or write something to the database, you have to use a callback. That whole Node callback hell thing.
Right.
That's actually its other innovation. Most programming languages have let those be synchronous responses. So what happens is if you want to know the contents of a directory from a database, that's actually doing a lot of resources. So your thread just, you're asking the operating system for that information, but it takes like if you did like a chart of that compared versus how much time executing code in memory takes, it's like freaking walking to Australia versus walking next door. That's so the bulk of the time spent in most languages when you're using those APIs is just spitting threads. What it did is by using that syntax, it says it brought that JavaScript philosophy of like, well, your code is never doing all that much at one time to the server, and basically now, so your JavaScript code does run. So when you hit a request and your JavaScript code starts running, no other requests can get served, but the very first time you hit one of those node style APIs where you go to the database or go to, it's everything else gets put on an event loop. So you're done running those codes. So the thread is free to serve other requests. And because the way Node is typically written is that happens like, half a dozen times in a single request. It can multiplex everything together really, really well, and it just happens to work. That's what's going on with Node. And then now, of course, C# and all the other languages. So it's like, yeah, that's a really good idea. Duh. So, now C# has async and await, which now can take advantage of that concept plus multi-threading, which is going to, ASP.NET has even better numbers than Node because of that. That's pretty much it. Yeah. So, yeah, the event loop thing, it's a separate, but there's parts of it that kind of reminiscent of threading. Just remember, they're not executing at the same time. It's only one thing's actually executing at a time. And even getting into the real low-level concepts. Anyway, we are at the hour, we spent a lot of time talking about this stuff.
Thanks, George.
Yeah, the only other thing I wanted to mention was that ITT Tech is shutting down.
What?
They basically there was an injunction that their students cannot receive federal funding or something like that, or they can't because and basically because they just prey on people that cannot get other funding. They can and like tie them down with high loans. They're shutting down. They can't keep making money hand over fist from that
But just
anymore.
because it's a blatant scam, I mean, come on.
Just
That's
because it's an
terrible.
obvious scam. Yeah. All right. So that's it. I guess we can resume later on. Hopefully, we can get Claudio next time. JB will be back. Get a little more discussion of writing. All right. Thanks, man.
Okay, cool, guys.
I'm going to end this. Bye.
Okay, bye.